Good morning, children. In today's lecture, we will be discussing some of the properties of electric current. Likewise, in the previous lecture, we understood what is electricity, about the charges, about the various notations used in electricity like electric potential, potential difference. Then we came down to the Ohm's law, then resistances. Then we saw the different kind of combinations of resistances like the parallel combination as well as the series combination. Then we talked about the color coding of the resistances. Fine. Now, as we know that there is a current, that means what is a current, students? Yes, you are right. Current is basically the rate of flow of charges. Now, the things are, if through a cross section of wire lots and lots of charges are moving from one place to another, obviously due to the movement there will be a kinetic energy, and due to that kinetic energy there will be a generation of heat. Okay. So now today we will be understanding that particular thing only, that is coming under the thermal effects of electric current. Okay. As per the equations of current, what do we have? Q is equal to I multiplied by T. Now, what is Q? Q is the charge, then I is the current, and T is the time period. Okay, time period for how long the charges are flowing. So, this is the equation which we are having over here. Then in per second or per minute, whatever the time frame we are taking, the number of charge that flows through the circuit is denoted by the current multiplied by the time. We can write it in words over here, current multiplied by the time. Now, this is very simple. Now, as we also know that there are some relations regarding the potential as well as the work done is there, and we have a relation in terms of potential difference as well as the work done, that is W is equal to V dot I dot T. Now, what is this equation? W over here is the work done by the charge from coming from one point to the other. V over here is the electric potential or the potential difference. I over here is the current flowing through the circuit, and T is the time frame for which the current is flowing. Now, since this is a form of energy, so we can replace W by H. Okay. Why we are replacing H? Because this is also a form of energy. And over, if there is a cross section of wire and the charges are flowing, and this will generate a heat because of the kinetic energy of the moving charges. Okay. So, H is equal to V into I into T. This is what we land up. Now, we know from equation over here that Q, that is the number of charges, is basically the multiplication of current and time. Now, this part of the equation, we can retransform the equation as H is equal to V into Q. This is another form of equation which represents heat. Okay. Now, we are using Q over here in place of IT as Q is equal to I into T. So, there are various types of variations over here which we can do. Now, let us come down to another variation with this. What we have is H is equal to V into I into T. Okay. This is the equation which we are having. Now, we can also change this symbol. For example, you understand, if you are having any numerical and you want to use an equation which is voltage independent, That means you don't have a potential difference in your question. So definitely you will be using an equation to solve the problems which is voltage independent. Now how to make this equation as a voltage independent? Okay. Now we see through Ohm's law. What we see through Ohm's law? V is equal to I into R. This is the relation which we already have. Now, if we replace this V by this value, our equation holds as I R in place of V into I into T. Now, what do we have? I into I, it is I square R T. So, this is another form of the heat equation which we have, and this equation is independent. It is independent of potential difference. So various type of equations are there which can be used over here, and one very important thing which we can notice through this is, I will just use this part of the board so that I am not rubbing any of the things, so that you are able to see each and every combination and each every relations. I am using this part of the board to continue further. What do we have? This is H is equal to I square R T. Now what does this interpret is, H is directly proportional to T. Now what do we mean by this? H is directly proportional to T. Also H is directly proportional to the square of the current. We get the inferences from these two equations. Now heat is definitely very dependent on temperature, or it is proportional to temperature. The more the temperature, the more time. The more the time it takes for the current to flow or the charges to flow, the more heat is generated. Similarly, if we come down to this equation, the heat is directly proportional to the square of the current. Means if you increase the current, or if you increase, the heat also increases exponentially. Okay. So due to the maximum flowing of current, due to the long duration, the heat obviously continues to change, and we get the heating effect of electric current. Now the basic question is, why do we need the heating effects of electric current? Can you just say, where are we using the heating effect of electric current or the thermal effect of electric current? Can anybody tell me? Yes. Have you ever seen an electric bulb, the tungsten filament bulb? What we are using over there? We are using the tungsten filament, and that filament is getting heated and it is emitting light as well as heat. So that way you can use that heat. That heat is dissipated in the atmosphere and is always doing what? Heating the things. Secondly, the girls specially, you are using the hair straightener and all the things. They are also using the heating effect of electric current. There is electric heater. The nichrome wire is heated so much that it starts emitting red light, as well as it gets heated up, and that heat can be used for cooking and keeping the room warm, etc. So students, I think by these equations and by the explanations, we are very much clear about the heating effect of electric current. In my next lecture, I will be talking about the electric power. The continuing part of this, we will be doing the electric power. After the thermal effect of electric current, we come down to another physical factor which is related to your electricity, that is electric power. Now what is electric power? The rate at which the electrical energy converts itself into other forms of energy is called electric power. I repeat, the rate at which the electrical energy is converting itself into another form of energy. As you know, there are various forms of energies, light energy, wind energy, and the different kinds of energies. So electrical energy, in whichever form it is being converted, it is called electric power. Power can also be defined as the rate of doing work. That is, P in mathematical terms is W by T. This is your work done per unit time. Per unit time. This is in seconds. Okay, so this is electric power. Now, from the past examples we have seen, or the equations we have seen, that W is equal to V into I into T. Why are we doing this? Why can't we keep this thing as it is? See, there are various kind of numericals which are being asked in your 10th board examinations, and that it is not necessary that you will be required to find the power and the work done will be given to you or the time will be given to you. No, it is not necessary. There are other parameters also which can be given, and if at all there is a condition like that, and under that conditions what you need to do is you need to transform this basic equation into the other forms of equation. Like we have power is equal to W by T, and now we also have W is equal to V I T. So we will replace this W and we will be having power this as V into I into T, that is the value of W divided by T. This T and this T gets cancels, so P is equal to V into I. This is the most commonly used formula for electric power, that is, power is equal to the potential difference across the conductor multiplied by the current. This is the basic form of this equation. Its SI, or the system international unit, is watt. WATT. This equation has been found by Mr. James Watt, and while he was dealing with the heat and the Carnot's engine. So, in the honor of Mr. James Watt, the unit has been taken. Okay. Now, we have this as watt. Now, there are various other ways also in which watt can be converted into joules. We will be taking it in some other classes. Now, what I am interested more is transforming the equations from the heat equations. We can take it and we can convert it into the power equations. Also, we know that here it is W is equal to V into I into T, or in place of W you can also use your H. Okay, you can also use your H. Why? Because heat is also a form of energy. Now we are having P is equal to V into I. Now can we have another form of the equation of power? Yes, we can have. For example, P is equal to V into I we have, but as per Ohm's law, what do we have? V is equal to IR, therefore P is equal to I into R into I, the side. So we land up at another combination, P is equal to I square R. So in the end we can see how many type of equations do we have for electric power. First of all, P is equal to W by T. This is one equation. Then what do we have? Another is P is equal to V into I into T divided by T. That when it comes down, we land up at this equation, P is equal to V into I. Then we have P is equal to I square R. This is the third equation which we have. So these are the three variations of the equation of electric power which can be calculated. The power which you obviously calculate is of a device, right? So for example, we are having a heater. In heater, the electric current is being converted into heating energy. So how much power it is consuming, we can get the things from these three equations. Whichever way it is being asked, we can handle that thing. For example, this equation involves your work done and time. This has nothing to be related with your current and your voltage. This is an equation which is independent of work done and time. It is only depicting your potential difference as well as your electric current. This equation is independent of voltage, independent of time and the other factors. It is only having two factors, that is a current and the resistance. So whatever way the numericals are being asked in your science paper, you are well equipped with all the formulas and understandings, and you can very well solve the electric power. Thank you very much for the lecture, and please, if you do like the lecture, just subscribe to the channel and press the bell icon so that you will be getting all the notifications in time. In the next lecture, we will be continuing with the other aspects of electricity as well as magnetism. So be prepared for it. Thank you very much.